Welcome back, everyone. So what we're going to do this time is continue on with our investigation of the volume and density of a marble. Okay, so I've got my marble here. Here's the marble. He was dunked in water. I had to redo a measurement, which I'll discuss shortly with you. I normally don't use Kleenexes to dry things, but I don't have a paper towel on my desk, so here we go. All right, so let's take a look at our measurements from last time, okay? And then we will talk about how to get the additional values we need through calculation, okay? Measurement versus calculation. Yes, they are two different, if often related, concepts. Okay, and processes. So here we go. So we're looking at, let me see, can I annotate? Woohoo, I can annotate, okay. So we're looking at the spreadsheet that I created last time, and one thing that I've changed here is that I originally measured a volume of 20 from the beaker. That was an erroneous measurement. The marble's volume that measured from a beaker, okay, I remeasured. It should be 7.5 milliliters. Okay, I don't remember what was going through my mind. I think I just misread the gradations on the beaker, and so I somehow wound up with 20 when I should have wound up with 7.5. Okay, so the volume of a marble is measured by one of these 300 milliliter beakers that you definitely, absolutely, under no circumstances ever should hold over your keyboard like I'm doing right now. The volume should be 7.5 milliliters and not 20 milliliters. Okay, so that's part one here. And then, so all these measurements have been correctly obtained. Okay, so we've measured the mass of the marble, we've measured the volume in the beaker, we've measured the volume through displacement, we've measured the circumference of the marble with paper and a ruler, we've measured its diameter, and we've met with a C-clamp, and we've also measured its diameter with calipers. Okay, so what to do next? Well, next we need to figure out what its volume is. Okay, given this measurement here, we need to figure out what its volume is given this measurement here, and we need to figure out what its volume is given this measurement here. Each of these measurements will give a slightly different volume. Okay, and so that's what we're gonna go ahead and calculate right now. All right, so how in the world do we do all of this? Well, when we're doing calculations, right, we need to use math. Okay, and so how are we gonna get these volumes from circumference and from diameter? Okay, so let's go ahead and take a little trip into math land, and you can write this down in your notes. All right, because it's gonna be useful for you to know how these volumes were calculated. Okay, so here we go. So I'm gonna open up a whiteboard, and this is our first order of business. So let me blow this guy up. Come on, whiteboard, blow up. Okay, so in this calculation we're going to discuss. So I'll go ahead and get the panel going, and then I'll talk us through it. So let me pause the recording. Okay, so here on this page, we're going to learn about calculating a sphere's volume from its circumference. Okay, and notice there's no apostrophe in the word its. Okay, its possessive is its, no apostrophe. Okay, the pronouns don't use apostrophes to indicate possession. Okay, so in English. So here we go. All right, so we've got pi. So we're going through a good amount of math, and this is math you may not have seen so far. You probably haven't seen, and but you are likely to see a good bit of it next year. Okay, so we're going through it. I want you to have it in your notes. Don't feel like you'll be expected to reproduce this math on a test. The important thing for you to see is the relationship between math and science. Scientists need to be fluent in math, just like any writer or speaker has to be fluent in the language that writer or speaker uses. Okay, we as scientists have to be able to use math as a tool, on a regular basis. Okay, at any point in time, we've got to be ready to go with our math skills. So in this case, we're using math, right, to figure out the volume of our sphere, which is a little hard to measure with a ruler, right? From some other measurements that we can take using instruments like rulers and calipers and C-clamps and what have you. Okay, so so how do we do this? So first off, we have to be familiar with a number, and that number is pi. And pi comes from dividing the circumference of a circle by that circle's diameter. So early mathematicians found that whenever they divided the circumference of a circle by the diameter of that same circle, they got the same number no matter how big the circle was. And that number is pi. And pi actually goes on forever. It's an irrational number. So it just goes on and on and on, and there's no pattern to it. But we can approximate pi as 3.14159. Okay, and I put little dots there to indicate that the number just kind of goes on forever, but we'll approximate it as 3.14159. Okay, so it's just a number we're going to use. Now, here's the formula for the volume of a sphere. Okay, the volume of a sphere. So the volume of a sphere is 4/3 times pi times the radius of the sphere to the power of 3. Okay, so what in the world's going on there? So I'm drawing a circle, right, to illustrate. This is the radius of a circle, okay? A sphere is just like a three-dimensional circle. And so a sphere has a radius too, all right? And so the volume of that sphere is 4/3 times pi times that radius to the power of 3, right? And so radius to the power of 3, that just equals radius times radius times radius, okay? So I'm just helping you follow along with the math. Don't worry if you're a little bit confused, okay? You don't have to be super comfortable with this math yet, but it's a good preview for math you're likely to see next year if you haven't seen it already. Now, it turns out that we measured, okay, so we measured the circumference of a sphere. We measured the circumference of this marble by using this piece of paper, right? So like we wrapped the paper around the marble and said, okay, it goes around one time. And then we used our ruler to measure how long that paper was. And so we measured the circumference of this marble, right? And so we have this number, and that circumference of the marble. Let me pause really quickly and grab that number for us. So that circumference is equal to 7.82 centimeters, okay? And so we can find the radius of the circle. The radius of the circle equals 7.82 centimeters divided by 2 times pi. Okay, so mathematically, if we're comfortable with algebra, I'm just dividing both sides of this equation by 2 pi so that I can get the radius by itself. Okay, and if you're comfortable with that, that's great. If you're not, you'll see it again soon, don't worry. Okay, and so what that gives me for the radius, okay, is, let me go ahead and calculate this. I'll pause the recording while I calculate. Okay, so that gives me a radius of 1.24 centimeters. Okay, that's my radius. So volume, well, that's equal to 4/3 times pi times the radius cubed. Well, now we've got 1.24 as our radius, okay? So now we're gonna go ahead and find out what that volume is. Okay, and if we go all the way through with this calculation, what we find when we plug this guy into our calculator is that we get 8.02 centimeters cubed for our volume, okay? Which is equal to 8.02 milliliters, all right? That's the volume of our sphere, okay? A milliliter and a centimeter cubed are the same thing, all right? So now we're gonna go ahead and we're gonna put this information into our data table. So here we are with our data table. And so the volume from using our paper and ruler to get the circumference and then calculate the volume, okay, is 8.02 milliliters. Okay, well, what about the volume from this C-clamp, right? So I'll stop the share really quickly. So you'll remember that last time we used the C-clamp to determine what is it, C-clamp to determine the diameter of our marble, right? So we clamped this thing around just right, and then we measured with a ruler to see how much distance there was between the two ends of the clamp here. Okay, and what we got for our diameter there, okay? So for our diameter, we got, let's go ahead and share. We got 2.5, okay, 2.5 centimeters. And this is actually gonna make for very easy calculations. Let me show you. Okay, so now we're back at our whiteboard, okay? And we're still calculating the volume of a sphere, but we're calculating the volume of that sphere from the sphere's diameter, all right? So the volume formula stays the same, but everything that's new, I'm gonna put in red so you can see what's changing this time, okay? So it turns out that diameter, which we've measured, equals 2 times the radius, okay? And remember, the radius, that's the number we need to get our volume measurement, okay, our volume value. So how do we find that? Well, we saw from our measurement with the calipers that we got 2.50 centimeters as our diameter. So 2 times radius equals 2.50 centimeters. So if we divide both sides of this equation by 2, what we find is that R equals, okay, 1.25 centimeters. And we should feel good about that value because that value, 1.25 centimeters, is very similar, okay? Very similar to the value that we got last time, okay, from using circumference, okay? So for our circumference value gave us a radius of 1.24 centimeters, and our diameter measurement is giving us a radius of 1.25 centimeters. So our measurements are consistent to this point. That's very nice, okay? So we're gonna go ahead and plug in. This is 4/3 times pi times 1.25 to the third. And when we perform that calculation on our calculator, we get 8.18 centimeters cubed, which is equal to 8.18 milliliters, okay? So these are our solutions, okay? That's our volume of our sphere. All right, so let's go ahead and put this new value into our data table. So here we are back at our data table. We go 8.18, okay? 8.18, I think that's what we have. Let me double check, 8.18. Yeah, 8.18, very good, okay? And then now we've just got one more calculation to do, okay? So our diameter from the calipers was 2.44 centimeters. So let's go ahead and iron this guy out. Okay, so this calculation is gonna be very similar, all right? I'm gonna do some erasing here and we're gonna go back through. So in this case, just erasing, and we're gonna have, it's a very, very similar calculation. So what we had was 2.44 centimeters is our diameter. And if we divide both sides of this equation by 2, we find that R is equal to 1.22 centimeters. So I can update this guy over here. So my volume is going to be 4/3 pi times 1.22 to the power of 3. Okay. So take a little time to get all this down. It's a new calculation. Okay. I'm just plugging in the new values. All right. And then I'll go ahead and do this calculation while you got everything copied down. So I'm going to pause the recording. You go ahead and get everything copied down. Okay, and when we perform this calculation, we find that our volume is 7.60 centimeters cubed, which equals 7.60 milliliters, okay? So we're gonna go ahead and put that value 7.60 into our data table. All right, so 7.60, okay, very good. So now that we've got all of our values here, right? It's time for the moment of truth. Okay, it's time for the moment of truth, and that moment of truth is what the actual value of a marble is versus what we got. Okay, so what in the world is that actual value, and what were our percent errors? Okay, so we're going to do 1% error calculation on the whiteboard, and then I'm going to show you how to automate percent error calculations in your spreadsheet. Okay, so that you won't have to do this calculation, because look, we've got 1, 2, 3, 4, 5% error calculations to do here, because we're gonna do the percent error just for the volumes. Okay, just for the volume measurements and calculations. So you won't have 1, 2, 3, 4, 5 of them to do. You'll just do 1% error calculation, and then I'll show you how to extend that out throughout your spreadsheet, okay? So let's go to the whiteboard for that percent error calculation. And I'll clear this whiteboard, and I'll pause the recording really quickly to get everything set up. Okay, so we're back at one of our percent error calculations. And so we remember that percent error is the absolute value of the accepted value minus the experimental value all over the accepted value. Okay, so what's going on in this case? So our accepted value is 7.60 milliliters. Okay, that's our accepted value for the volume of this marble here. Okay, and we subtract from our first calculation was with our beaker value. Okay, or so our first measurement was with our beaker value, and the beaker value, as I told you, is actually 7.5. So I got 7.50 milliliters when I went back and performed again that measurement, which I had performed incorrectly the first time. And so 7.60 minus 7.50, all divided by the accepted value, 7.60 milliliters. Oh, we have to multiply by 100. So we have to multiply by 100. Okay, times 100, very good. And what's that gonna give us? So I will tell you in just a second. This gives you 1.32%, okay? 1.32%, that was our error, all right? 1.32%, okay. So go ahead and get that copied down, and then in just a second, we're gonna head back to our data table, all right? So we're gonna go back to the data table. Feel free to pause. We're gonna go back in 3, 2, 1, okay. So we got 1.32%, right? But notice I'm not actually copying that value down. Instead, I'm gonna go ahead and say percent error right there, because that's what's gonna go, I'm gonna make it bold. Okay, that's what's gonna go all the way across this row. Okay, not that far, but right there. Okay, percent error. And how am I gonna set that formula up? Okay, so it turns out that Google Sheets is super useful, right? And when you want to, you can enter a formula into Google Sheets. So I'm gonna go equals, okay, ABS for that's the absolute value, okay, of 7.6 minus, and now I'm gonna reference this particular cell. So this is B2, cell B2. Okay, you see it's in column B and it's in row 2. So if I type B2 there, Google Sheets knows that I'm talking about the value in this particular cell. Okay, all divided by 7.6. Okay, and then I have to go times 100. All right, and I hit enter. Whoop whoop. Okay, that gives me the 1.32%. Now it's an ugly decimal, and there's a way to round it to 3 significant digits. But I don't actually remember how to do that. So we're going to leave these guys as big, ugly decimals for the moment, and then we'll come back on a separate video and knock them out, okay? And what's really cool is now I can just drag from this, you see this little bottom corner here where this little square is, okay? I can just drag from here all the way to the right, okay? And then I get my new percent error measurements, all right? So the calipers gave me 0% error, okay? The calipers gave me 0% error. That's crazy. The C-clamp gave me about 7.5% error. The paper and ruler gave me 5.5% error. The displacement method, okay, the one when I dropped the marble into the beaker and it spilled water, it gave me 34.2% error. The beaker, not bad at all, okay? Just this regular beaker here, just wow, that measurement ended up being spot on with 1.32% error, okay? So that's how we can do 5% error calculations fast, quick, all right? So let me go ahead and stop my screen share. Okay, so that's all for our data calculations today, okay? Our data table and our calculations, okay? So you're gonna use the same methods to remember, calculate the volume and then the percent error values for your measurements, okay, regarding this golf ball, okay, or your golf ball. It might not be a Bridgestone, all right? So that's all for now. Good luck, and may all of the forces be with you.